is the first rule of factoring?
To find the greatest common factor.
GCFs. GCFs are always what you want to look for first when you're going to factor stuff out. Remember, the difference between factoring and solving is that a solving problem uses factoring, but there's an equal sign. That means you would be finding your zeros at some point. So remember, the first rule of factoring is always to look and see if there's a greatest common factor. So if I'm looking at 4x squared minus 24x, what's my GCF?
X.
4x or 4x? 4x. Okay. So if I factor out a 4x, what am I left with on the interior? Is there anything else I have to do? No. Is there an equal sign? No, and I'm done. There's nothing left to do. The other style of factoring is when you had a first term coefficient not equal to 1. We had to factor stuff by grouping. I want to revisit that as well. So if I look at 2x squared, 11x, plus 11x minus 21. When I go to factor this one, remember, you multiply the first number and the last number. I get negative 42. What times what is negative 42? But when you add them together, you get positive 11. If you don't remember your factors, what could you use right now to help solve that issue? 14 and 3. Your neighbor, but remember that got you in trouble last time.
I was right this time. It was actually 14 and negative. Yeah. Sorry.
14 and negative 3. All right. Now, what we do with this, is remember, we're doing something called split middle term, factoring by grouping. The trick with this was that if I have a positive and a negative term for the middle now, I usually put that negative term in front. So I get 2x squared minus 3x plus 14x minus 21. And again, really the only reason why I'm doing that is just makes my signs a little bit cleaner to work with. And now I'm grouping again. The kind of the dead giveaway for a grouping style problem is that you're always going to have 4 terms. You're always going to have 4 terms. What's the GCF of 2x squared and 3x? Good. You factor out the x, you're left with 2x minus 3. Again, GCF of the 14 and the 21? 7x. Which is 7. And I'm left with 2x minus 3. Are those two the same that are in the parentheses? Yeah. So I write it down. And what was left? Yes, sir.
If you would have factored out something else for the second part, and instead of 7, you didn't get 2x minus 3, it would just not work.
It means you did something wrong.
You have to have the same 2 things.
Yeah, because what you're doing here when you're grouping, once you get the first GCF out, these 2 terms should wind up being the same. If they're not, that means the first thing you factored out might not have been the GCF, or you messed something up with the second one. Yeah.
Do we have to factor everything out, or can we just do it? Because I was able to do math where it was, I knew 2x times 7 is 14x.
Oh yeah, if you can factor it mentally, like a guess and check method and stuff like that, that's fine. I'm not going to say no.
Okay.
I'm just showing the method because what's going to happen today is that we're not dealing with just quadratic anymore. We're dealing with upper degree polynomials.
All right.
So it just takes a little bit more work. That's all. Okay? So it's going to look like stuff like this then. What's that? Now, this is called sum and differences of cubes. Those are third degree polynomials. Their exponent is 3. They mirror what you guys have seen before with something like this. If I had to factor x squared minus 4, you guys recall I would ask the questions, is this a perfect square? Is this a perfect square? Is this a subtraction symbol? Did we say yes to all of that?
Yes.
So what's the square root of x squared? What's the square root of 4? So you would write out your terms as x plus 2 and x minus 2. And that's what we have done with difference of squares. What changes when you have difference or sums of cubes? Oh, speaking of which, could I have done this if it was x squared plus 4? Could I factor if there's an addition symbol between those two? No, I cannot factor that. I could solve it, but I can't factor it. So when I'm looking at cube, instead of asking is it a perfect square, I'm asking to see if it's a perfect cube. Cube roots. Think of it as 2 cubed is 8, 3 cubed is 27, 4 cubed 64, 5 cubed 125. After that, I think 6 is 216. But if you don't remember if something's a perfect cube, there's a button for it. If you look at your calculator, if you hit the button that says math, there's a cube root function. It's the fourth one down.
Or you could just use
If I'm doing cube roots, though, if I want to take the cube root of 216, but I know what you mean by cubing. Yes, I can use the caret button to cube. But if I want to take the cube root, go in the other direction instead of squaring or taking the square root, it's just going the other way. Right. Just so you guys remember, that's how we check this stuff out. Now, the patterns for sums and differences of cubes, is actually pretty easy after you get through it. If you look at x cubed plus 27. I'm going to walk you through the pattern. Again, we ask the question, is x cubed, is this a perfect cube? Is this a perfect cube? Okay? And remember, when we're dealing with a perfect cube, it doesn't matter about the signs. And there's always going to be a pattern for the signs. This is a plus symbol, correct? I don't know, is that your texting there?
No,
Okay, just wondering.
I was using my phone.
Yeah, and I'm 8 foot tall. So again, is that a plus symbol? Since this is a plus symbol, I automatically put another addition symbol there. Now, what happens is I'm going to create the sum of cubes here. When I factor it, it's going to have two parts. It's going to have a binomial and a trinomial. Binomial means there's 2 terms, trinomial means there's 3 terms. The binomial part, the 2 part, well, what's the cube root of x cubed? What's the cube root of 27? Now the trinomial part will have 3 parts, which means it's going to have 2 signs. Well, since this first one was a plus sign, the next one will be minus, and the third one will be plus. It's the pattern. What's x squared? What's 3 squared? What's 3 times x? Okay. So the pattern that works for sums or differences of cubes kind of follows the same idea here. We have, if it's an a cube and a b cube, your pattern is always going to be a squared plus b squared. Oh, excuse me. I'm ahead of myself here. A plus b, a squared minus ab plus b squared. If the signs were opposite, and we have, can I scroll this up a little bit? Let's say we have x cubed minus 125. Again, is x cubed a perfect cube? Is 125 a perfect cube? Yeah. Okay. We're starting this problem out with subtraction symbol. What do you think is going to go in your binomial? Yeah. Nobody got it.
When, if in the second parenthesis,
Mhm.
if a is squared,
Yes, I forgot to say that. Sorry. I said it, but I just didn't write it down. Thank you. So again, since I have a difference in cubes now, my binomial part, I keep the sign. What's the cube root of x cubed? Cube root of 125. My trinomial will have 3 parts, but it's going to have 2 signs. Well, I started with a negative. What's my next sign going to be? Positive. And here's the kicker. The last term is always positive. Okay? The last term will always be positive. So, now I have x squared. What's 5 squared? And then what's 5 times x? So your difference. Okay? Yes, sir? No, this is used for factoring cubes.
So there's not going to be word problems with this?
There might be.
But not today, right?
There might be.
You got that.
Okay? It's factoring and solving an equation with something thrown in here like this. Let me show you another example. I think 216 is.
Yeah. Yeah, it's a cube.
I don't know if it's 216 or 316. Just double check.
Oh, it's 8 or 6?
Is it?
6? It's a 6,
Yeah.
not 6.
It is 6? Okay. Again, in this case here, I have, is 8 the perfect cube? It is.
It is.
2 times 2 times 2. All right. 216 is a perfect cube. And in the middle I have subtraction. Yeah.
Yeah,
You get 27, yeah.
Okay.
So then we're
so then
back
it's
to
the same exact problem.
Yeah. You're just having a GCF then. Now, top drawer on the left there. Okay. What I was just trying to get at was showing you, that's what happens when you make a problem off the top of your head, you get all the other stuff. Since this is a perfect cube, what's the cube root of 8x cubed? 2x. Perfect cube here is 6. What they're doing there, since you can divide them out by 8, they're taking that GCF out. So technically, yeah, that would have been the right way of going. But for example-wise, I'm just showing the pattern again. Your first sign was negative. What are the next 2 signs going to be? Good. When I take 2x and I square it, am I squaring just the x, or am I squaring both the 2 and the x? 2 and the x. Because the a value is 2x in this case. So it would be 4x squared. What's 6 times 2? And 6 squared? And Kayla, you were right when you said that, okay, you could divide it out by 8, because here is a GCF, right? If I take out a 2, I have x minus 3. Here there's a GCF of 4. What's 2 times 4? And this part here would have been the same as 8 times the quantity x cubed times 27. It was just dumb luck that I tried to show you an example with an a value that had 2x in it or something. Okay. Sums and differences cubes are a very simplistic pattern to follow with, but it also allows us to do even more fun stuff. Oops. More grouping. But notice, what's my degree now? Degree, when I'm looking at degree, it's always the highest exponent.
Oh, I thought.
Yeah.
When you rather have this, like, weight
all honesty, I would do it right away. I was just, like I said, it was dumb luck that I had picked two that worked out. I won't be able to do that ever again off the top of my head. In this case here, if I want to factor this out, it's a third degree polynomial. We've done grouping problems before with squared x in terms when you split your middle term out. Does that style change? No. You're still breaking it apart and looking for your GCFs in two separate terms. So you have x cubed minus 2x squared. If I group that, what's the GCF? X squared. So you take out the x squared, and you're left with x minus 2. If I break this apart as well, what's my GCF of the negative 9x and an 18? 9. It's 9, but I want to take out the negative 9. And I have x minus 2. Are these two guys the same? All right. Write it down. Am I done? No. Why? What do I have now? No. I'm factoring. What do I have left?
Zeros.
What's that?
X squared and 9.
X squared and 9. Isn't that a difference of squares again? Oh no. So what's going to happen sometimes, you might be led into another difference of squares or something else that you can factor out a little bit further. Remember, you're dealing with higher degree polynomials now, and as you get into this, you'll start hearing me ask a lot of times, well, what's the degree of the polynomial? You guys would say it's a third degree polynomial. How many possible zeros could we have? We have 3 possible zeros. In this case here, I'm not asking you to solve for your zeros, but if I asked you to, could you tell me the 3 zeros of this?
2, 3,
Yeah, 2, 3, and negative 3. So the only thing that changes when I throw an equal sign in here is you set your zeros there. That's the only thing that changes. All right. 81x to the 4th minus 16. Well, it's x to the 4th, so. You're close. Now, hold on. We have 81x to the 4th minus 16. Is 81x to the 4th a perfect square? What's the square root of 81x to the 4th?
What?
9x squared. Okay.
Oh, I get it.
Is 16 a perfect square? What's the square root of it?
9x squared minus 4.
Is this a subtraction symbol? So, this is also a difference of squares, which means your two terms would have been 9x squared plus 4, 9x squared minus 4. And I'm still not done. Can I factor both of those?
No. Go back to the last one. You can. You just factor out the,
Factor out
the
I.
You can do
Hold
the
on.
right one.
Hold on. Can I factor this one any further?
Oh, yeah.
No.
Can't you factor out the
Do that one, take the square root over additions.
I can't take square roots over the additions. You can't take a square root over the addition symbol here. You just can't.
But you can over negative.
Or I mean, like.
No, because here, when I come over here, is this a perfect square?
Yeah.
Is this a perfect square?
Yeah.
Is that a subtraction symbol?
Yeah.
Okay.
Why can you
Oh, that's
That's
what I meant. That's what I meant. I just didn't know how to say it.
Okay. Because here I can't do that because of the addition symbol.
What would you call it if you had the 4 root everything? You can't have.
It's just the fourth root. Yeah, it's just fourth root.
Is there a word for it that we just don't have to know?
I'm gonna call it the
No.
5th root.
It's just the fourth root. It's a quartic, I believe. I think. Don't quote me on that. Okay. Stop talking, Stinky.
Yeah, okay.
4x to the 6th minus 20x to the 4th plus 24x squared. What's your first rule of factoring? You go with the GCF again. What's the GCF on that one? 4x squared. Now you have 4x squared times the quantity x to the 4th minus 5x squared plus 6. What would you have done if you had to factor this? How do you factor that? -2 and -3, very good. What is the difference between this and this? More x's, yeah.
It's all squared.
What I want you to take a look at how the exponents work. This goes from a 2 to a 1. 8's cut in half, right? This goes from 4 to 2. It's cut in half again, correct?
Zero cut in half is 0. There's no exponent of 6. That's when it's 0. That's an exponent of 1.
That's just an exponent of 1. Looking at each degree, each part of this has a different exponent. Okay. Now, what happens here, since these exponents are being cut in half on the way down, you can still factor this the exact same way you would if it was x squared minus 5x. 4x squared, x squared minus 2, x squared minus 3. And it works the same way. It works out the same way. In this instance here, can I factor any of those any further? I have x squared minus 2. It's a subtraction symbol. X squared is a perfect square, but it is 2 a perfect square. Same thing with the 3. It's the 3 a perfect square. And I'm done. That's fully factored. Okay? You can do this factoring as your exponents are decreasing like that, and they're getting cut down in half. You treat it the exact same way as you would a regular trinomial. Okay? Because if you FOILed that out, you would get, x squared times x squared gives you x to the 4th. All right? Let's try another one like that. Very similar, but I put one other part to this. What did I put in there? I put an equal sign. So after we're done factoring this, what do we have to get? Your zeros. And I heard you guys already said, bring it over. So we have 2x to the 5th plus 24x is 14x cubed. So when we started out, we bring over the 14x cubed, so we have 2x to the 5th minus 14x cubed plus 24x is 0. And we start again with the first rule of factoring, which is 2x. Do my exponents decrease like they did in the earlier example, where I'm going to be able to do my factoring of like I would a regular old trinomial?
Yeah.
All right, what are your two terms then? -3 and -4. 2x, x squared minus 4.
3 zeros with this, since you would have 3 terms. Even though one of them would be 0.
Ah, ask that question again. What's your degree of this polynomial? Okay, so how many possible zeros can you have? Okay, what are your zeros? Can I answer that question from what I have right here?
Yeah.
Okay, what's my 0 here? I have 2x is 0. 0. What's my 0 here?
2.
No, 4.
And then what's the other one?
-3.
Plus or minus? Well, right now you only have 4 zeros.
So, plus or minus 2.
Thank you. Remember, you're adding 4, so you have x squared is 4, so x is plus or minus 2. Add 3, you wrote plus or minus 3. Yeah,
You'd have to put x squared minus x minus 2 and x plus 2, right?
you don't have to. When you're, and this has come up in each of the other classes today so far. When you're solving for your 0, you don't need to factor out this completely to go x plus 2, x minus 2. You don't need to do that. If you want to, go for it. Not a big deal. But if you get to a part like that and you can set them to zeros, that's fine. Now, everybody sees that we have 5 zeros here. I have 0, positive 2, negative 2, positive root 3, negative root 3. Oh!
Wait,
Yeah.
so your zeros are just kind of a large distance.
Yeah, and that's possible.
And what did everyone else? Oh,
There's only 3 different numbers here, but with the plus minus, that means there's 0, positive 2, negative 2, positive root 3, negative root 3. So I have 5 possible zeros. No. Okay. If it was to the 7th power, we could have 7 zeros. I'm using the word could because sometimes our zeros are imaginary. So just so you guys know that there are possibilities of having I know it does. Yeah. It's an increasing function that goes up, down, up, and all that.
It's something like that.
Yeah.
Not slow.
All right, try another one. Run a little. Remember, the dead giveaways, when you see 4 terms, what are you probably going to be using? Starts with a G and ends in a root. Starts with a G and ends in a root.
grouping.
Oh, root. I said root.
Yeah, that's not
And he goes, oh, greatest common factor. Starts with
No,
a G.
great friend.
Oh, greatest common friend? What is that? I never heard that one. It's the person that everybody wants to hang out with? Okay.
How far I got?
But group them.
Now.
I
The
used
X,
to.
right?
Oh,
Oh, now I remember. Yeah, I didn't know.
yeah, I didn't know where you.
Usually what you're when you set up a grouping problem, you put it in descending order and you group them like that. That's the best way to group. And once again, if I look at that, yeah,
Why did you put plus minus 12 if it's just a negative 12 or maybe minus 12?
because whenever I have that third term as negative, I usually do plus minus to remind myself to factor out the negative. That's all. And if I'm looking right at those 2 terms, could I list my zeros, or do I have to write them all out? What's your 0 going to be here for x squared minus 4? Plus or minus 2. And the other 0 is going to be subtract 7, divide by 3. And there's your 3 zeros. It's just factoring with a little bit, the same style of factoring that we've been working on. All the rules still apply. None of that has changed. You're just going to have a little bit like an extra step here or there. Yeah?
Isn't it 3x plus 7 times x minus 2 times x plus 2?
And yeah, and you can write that out if you'd like, and that's what he was saying too. You can have x plus minus 2, x plus 2, and then go 3x plus 7, all equal to 0. Sometimes if you do it that way, you'll know not to forget it's plus minus 2. What I'm saying is that if you have to solve a 0, and you get to this part where it's x squared minus 4, if you can do that, just add 4, take square root, get plus minus 2, that's fine. I'm not requiring that you go to this step. Now, I do require it if it was just a factor. Does that make sense? So sometimes you get a little leeway when you're just doing the factor, when you're solving stuff out like that. Let's see. Do these, please. You're on paper again.
I'm not sure. Probably. Yeah. Yes. Probably out of paper.
Oh, Andrew, what are we gonna do about it?
Get new paper?
Yeah, I got some blank. There's some paper back here you can use. I got. You have to keep mooching off the wall. The three sports that I played all the time was hockey, basketball, and swimming. They happen to be all in the same season, so I swam.